Okay, we are finishing our 4.4 notes. We need to talk about the distance formula. You should already have in your notes from yesterday the distance between 2 points is given by the square root of x2 minus x1 squared plus y2 minus y1 squared, where x and y's make up points, 2 different points. Okay, for this problem, they give us 2 points and they show us the graph of those 2 points. In the warm-ups yesterday, we had to find the distance between a couple points, but one of the coordinates stayed the same. Like either the x was the same both times or the y was the same both times, so we were able to just count the spaces. It was either a horizontal or vertical line. If the line is at some sort of slope, we are not going to be able to just count spaces. It does not work that way. We have to use this formula. Counting the spaces might get you an answer close to the correct answer, but it's usually not going to give you the actual correct answer in most cases. Maybe sometimes we get lucky. So we go to these 2 points that they give us, either written out or on the graph, and we need to label them as x1, y1, x2, y2. It does not matter to me which point you want to think about as your 1 or which point you want to think about as your 2. You just have to be consistent.
We gotta write this down.
Now all I have to do to find that distance is plug these numbers here into the formula I wrote at the top. So the distance between KL, we would write the letters KL without a bar over it. That means the measure or distance is equal to the square root of my x2, put that above 4, minus my x1 is negative 1 squared, plus my y2 is 2, minus my y1 was negative 2. Alright, the only thing left to do is to calculate it. So, 4 minus negative 1. It's really like 4 plus 1. Jaden is 5. That's still going to get squared. Plus 2 minus negative 2. John? Is 4. We're still going to have to square it. Who can tell me what 5 squared is? Honesty? 25. Somebody new for 4 squared. Keon? 16. Then I have to add those together. Somebody new to add them together. Martez, what's 25 plus 16? 41. And then we have to decide if we can simplify the square root of 41. Well, the only 2 numbers that multiply to 41 would be 1 and 41. That means it's prime. It cannot be simplified when it's under a radical. So the distance between K and L is the square root of 41. Remember I talked about yesterday, I do not want these as decimals. I don't want them as rounded decimals. We'll leave them as simplified square roots. Alright, I'm going to give you a moment to work on these examples. The middle one, you might notice, is easier than the other 2. If you need to label your points, the x1, y1, x2, y2 above them, if that's going to help you, remember what gets plugged in where. You should have the formula on your page in front of you, but I will write it at the top of this slide again just in case. x2 minus x1 squared plus y2 minus y1 squared. All right, let's talk about number 7. To set this one up, I would have that the distance between A and B is equal to the square root of, if I labeled my points the way that I did with my x1, y1 at point B, x2, y2 at point A, but when I plug mine in, it's going to be 3 minus negative 2. If you did it the other way, that's fine. Our steps will start looking very similar very soon. Plus, if I labeled my points this way, my y2 is negative 1 minus 4 squared. Okay? Being careful to watch my signs. Now I take 3 minus negative 2, that's like 3 plus 2, that gives me 5. I'm still squaring it. Plus, this is where some people's answers will probably start to differ because we don't do this quite right. First of all, we have to take negative 1 minus 4. Now I'm hoping we don't have issues with our operations with integers, and then we all know that would be a negative 5, and that's getting squared. I put the negative 5 in parentheses on purpose. We have to square the negative 5, not just square 5 and keep it negative. If we square a negative number, it becomes positive. So when I square both of these, I'll get 25 for both of them. At this point, there should not be any negatives left. Once you square both of those numbers, the negatives are gone. Which is important because we can't end up with a negative number under the radical. If we have a negative under the radical, we did something wrong. Alright, then we add those together. We get the square root of 50, and then we have to simplify it. Did anybody simplify the square root of 50? We would break it into 10 and 5. And then the 10 breaks into 2 and 5. That means we have a pair of 5s. And what stays inside? A 2. So the distance between A and B is 5 root 2. Alright, if we have no questions on 7, I will erase a bunch of that so that we can talk about number 8. 8 is actually easier. We can use the distance formula, but we don't need to because these points are on a horizontal line. So what can I already tell that the distance is going to be? Julian says 7, and I would agree with that. If it's on either a horizontal or a vertical line, you can just count. To get from negative 2 to positive 5, I have to go 7 spaces. So the distance between C and D is 7. I'm only okay with you going straight to the answer if it is a vertical or horizontal line. And if you're not sure about that, then just go ahead and use the distance formula every time. If you use the distance formula, you should get the same answer. On to our last example, number 9. We've got our points E and F. I'm going to label this one x1, y1, label the other one x2, y2, and then just start plugging things in. The distance between E and F is equal to the square root of my x2 is 4 minus my x1 is negative 4. That whole thing gets squared. Plus my y2 is 2 minus my y1 is negative 2. Again, that whole thing gets squared. Subtracting the negative is the same as adding a positive. So really I've got 4 plus 4, which is 8 squared, plus 2 plus 2 is 4 squared. What is 8 squared?
64.
64. 4 squared.
60.
If I add them together, what do I get? 80. So I have the square root of 80. I'm running out of space, so I'm going to go next door over here. So right now I'm at the point where EF equals the square root of 80. Is that simplified? No, we can break 80 down. What will 80 break into? 10 and 8. 10 breaks into 2 and 5. 8 breaks into 4 breaks. Okay, what do I have pairs of? How many pairs of 2s? 2 pairs of 2s. If I bring both of those out, multiply them together, I get a 4 square root of 5 was left over. Now, if you were to break 80 down differently, if you broke 80 into 4 and 20 and broke 20 into 4 and 5 and circled a pair of 4s, I'd be okay with that. Either way, you should end up with 4 root 5. So that would be our final answer. The distance between E and F is 4 square roots of 5. All right, so by request, we're going back to example 5. It'll be good for us to review the Pythagorean theorem today. What is the equation that goes along with the Pythagorean theorem? David.
A squared plus B squared equals C squared.
A squared plus B squared equals C squared. What do we call A and B? What's the name for those sides of the triangle? The legs. A and B are the legs, and C is the...
Base.
Nope. Different triangle. Base is an isosceles for a right triangle. The other side is called the hypotenuse. Very good. So we've got our legs and our hypotenuse. The hypotenuse is always across from the right angle, and it is always the longest side. So we go across from the right angle. This has to be side C. They labeled A as the one that we're missing, so I'm going to label 8.4 as B. All right, then all that's left to do is for us to do is plug in our values and figure out what the side length of A is. What am I going to plug in for A? A, we don't know it. A squared plus, what's going in for B? 8.4 squared equals, what's going in for C? 11.9 squared. Now you would pretty much certainly need or want a calculator on these. So if we square 8.4, we take 8.4 times 8.4, David, what do we get? 70.56, and that's not rounded, correct? Okay. All right, and then 11.9 squared? 441.61? Oh, I thought that seemed big. 141.61. Sounds better. All right, then we have to solve for A. First thing I need to do. I heard somebody whisper subtract, which is correct. Subtract the 70.56. Are we all ready to continue? So we're left with A squared equals 71.05, but then we're not finished. What do we still have to do? Square root both sides. To undo a square, we have to take the square root. Now this one, of course, we're not going to be able to simplify like I want you to. So in this case, I would accept two things. I would accept it if you were to leave it as the square root of 71.05. Usually we do not like decimals under a radical, but I'm not going to give you a question like this very often, probably ever. Or we can approximate it. This would be the only time we would round. David, what did you end up with?
I didn't round it, but I split 8.429.
8.429. So I'm going to take that to 8.43. Right? The 9 would make the 2 go up to a 3. Notice that I put a squiggly equal sign to say that it's approximate. That's not an exact answer. So there it is. Now we can check the reasonableness of our answer. I know that this is at least reasonable because A is smaller than C. If you were to end up with a number bigger than 11.9 in the end, that is wrong. C is the hypotenuse. It has to be the longest side. So you can use that as a small check for yourself when you're doing these. Make sure that C, or the hypotenuse, is always the biggest number. If it's not, then you most certainly did something wrong.